All right, this video will go through the basics of surface area. Surface area, the easiest way to think of it is if you were trying to paint the object, how much paint would you need to cover it? If you were to try to cover all the outer surfaces. Um, Sometimes there are formulas, okay, like for cylinders or cones. But sometimes, like for prisms, we often just have to think about adding up all the surfaces. There's no easy formula. You kind of just need to use a little bit of common sense and some, organized thinking. And I'll go through some examples of how to do that. But any formulas you will not need to memorize. Okay. Um, Again, starting with sort of the easiest shape would be a box. Now, volume would be very simple, right? We would just do 4 times 10 times 17, but surface area is going to be a little more involved. So we think of this is really composed of a bunch of rectangles, and this rectangle would be 4 by 10, right, which would be 40, but there are 2 of those. Okay, so we're going to set up the calculation. This rectangle on top would be 10 by 17, but again, there are 2 of those, right? Because there's the one on the top and the one on the bottom that we can't see. Same thing here. There was one in the front and one in the back that we can't see. And then finally, this rectangle here would be 4, right? The thing is 4 units high by 17. And there are 2 of those. So this would be, what, 80? This would be 340. And this would be 8, 10, 17. Hold on. Arithmetic, not my strong suit, as you know, 136. All right, and then we'll, add those up. So 80 plus 340 plus 136 gives me 556. And if this is centimeters, then this is centimeters squared, right? So volume is cubic units, but area, like always, we measure area in square units. All right, another example would be a cylinder. Now, cylinders have a nice formula that we can use. The 2 pi r squared is the circle at the top and the circle at the bottom. And the 2 pi r h takes care of everything else, takes care of the lateral side. Okay, so we would simply say 2 pi r h, right, those are given to us, and then 2 pi r squared. And then just clean that up. So it's going to be 8 times 12 is 96 pi, and that's going to be 16 times 2 is 32 pi. Altogether is 128 pi. If this is inches, this is inches squared. Okay, pyramids can be a little more tricky. In this case, they are giving me the height of the pyramid. Okay, is 24. Let's see. So how do I add up all the surfaces? Now, there's no nice formula for this, so I just need to think about, let's assume the base is a square, by the way, just to make this easier. So, okay, well, let's take care of that. That's easy. All right, so surface area is going to equal 16 times 16 plus, now whatever triangle we end up finding, right, hopefully we agree there's going to be 4 of them that are identical, because these are all the same all the way around, and the height's all the same all the way around. So let's say 4 times 1/2 times, right, because it's 1/2 base times height for a triangle. We know the base, okay, except we don't know the height, right? So we don't want this height like we wanted for volume. Now we actually want the slant height. We want this height. Okay, that's annoying. But okay, we can just use Pythagorean theorem. We know how to do that. 8 and 24, right? So this is 16, but it gets cut in half. So okay, so now we gotta, do the Pythagorean theorem. 8 squared plus 24 squared. All right, so this is just, it's a little annoying, but we can certainly do it. 24 squared is 556 plus 8 squared is 64. 64. And does that work out nice? The square root of 640 something? No, it's not nice. We're just going to leave it as the square root of 640. And that's our height of our triangle. And, we can calculate that out. 16 squared is 256 plus, this will just cancel out to 2. 2 times 16 is 32. And that doesn't combine any further. Another example, cones, there's a nice formula. The S in this formula refers to the slant height, okay, which in this picture we do not know. This is the height, this is H, but we want this dimension, that's S. Okay, so again, this is where we just use Pythagorean theorem. Okay, so first of all, the radius would be 9. And so setting this up, this would be 21, right? Because this dimension's the same. And then we would solve for S. And we'll use a calculator. 21 squared plus 81 is 522, which is not a perfect square, so we're just going to leave it. And now we can set this up. Okay, so that is this dimension here. That is this slant height times pi times the radius, which we said was 9, plus pi times the radius squared, which would be 9 root 50 or 522 pi plus 81 pi. And as ugly as that is, that's kind of the best you can do. And again, if this was in centimeters, this would be centimeters squared. All right, a couple more examples. Triangular prism. Okay, so this time they're telling me the base is an equilateral triangle. Okay, this would be more like an honors level sort of question. So, well, first of all, equilateral means all the sides are the same. Okay, so that's helpful. So, hey, that means this rectangle is the same as this rectangle. Okay, so let's take care of that. Now, how many? There'd be 3 of those, right? So we'll say 3 times 6 by 4. Okay, that takes care of the rectangles. But now we need to add up, okay, there's also these 2 triangles. For that, okay, we need to know base times height. Well, it might help to draw it like this. So this is 4, and okay, well, I could draw, okay, I could use Pythagorean theorem. Okay, see, you see a pattern? We're getting used to like, oh, okay, if I don't know the height, I can just go find it. All right, so let's, solve for that. So we'll do 4 squared minus 2 squared. And we end up getting 16 minus 4, so root 12, better known as 2 root 3, would be that height. And so the base of each triangle would be 4. And the height of each triangle would be 2 root 3. And again, there are 2 triangles. Oops. Hold on. There we go. So 1/2 base times height, and there are 2 triangles. So like when you calculate this out, this is just going to cancel out. That happens a lot. 3 times 6 is 18. 18 times 4 is 72. And then this becomes 8 root 3. Okay, so sometimes you have to bring in things like trigonometry or Pythagorean theorem, or how do isosceles triangles or equilateral triangles work. Okay, a sphere. The formula wasn't on the previous slide, so we know the volume of a sphere from before. Okay, we also now know the surface area of a sphere. Okay, is this formula here, 4 pi r squared. So this is an example of a question where you'd have to do a little more thinking. A regulation bowling ball is a sphere with a circumference of 27 inches. Find the radius. Okay, well, so we just need to work backwards. We know circumference is 2 pi r. Well, so that means if the circumference is 27, then that would just mean we would set up this and solve. And then take that and plug that in. Okay, so we would say surface area equals 4 pi, 27 over 2 pi squared. All right, and we would do that out. 27 squared, let's just use calculator, is 729. And then this would be, right, so you square all the things. So this would be 4 pi squared. One of the pi's would cancel. The 4 would cancel. And so that's your answer. And this is inches, so this would be inches squared. And finally, just to give you a more difficult example, not difficult because it's hard to do, but just difficult because you need to think a little bit if you were trying to find the surface area of this thing. Now, this is half of a sphere plus a cylinder. Okay, so, what's the surface area for a sphere? Well, it's 4 pi r squared, so we'll say 1/2 times 4 pi radius would be 6 squared plus, right, so we did the surface of the sphere, but now we need the surface of the cylinder. Okay, the surface area for a cylinder was this formula, 2 pi r h plus 2 pi r squared. But the 2 pi r squared, again, remember that covered the circle at the top and the circle at the bottom? We don't need both circles because this one isn't exposed, right? It's not an outer surface. So we're going to sort of just adjust our formula a little bit, and instead of using both circles, we're only going to use one. Okay, again, the 2 pi RH covers the rest of the cylinder. I switched the radius and height. I switched, but it doesn't matter because we're just multiplying. All right, and we would calculate this out. All of that would give us our answer. Okay, so sometimes you just need to adjust your formula a little bit based on what's exposed or not exposed, and that just takes a little practice. All right, those are the big ideas. So if you have any questions, again, please feel free to email me. Otherwise, thanks for watching.